And we're going to label some sides on it. A and B and C. And I'm going to go ahead and call this angle B right here, angle beta. We would have an alpha and a gamma too, but let's just worry about that one angle. So, guys, let's limit our comments to productive ones today, please. If I asked a 7th grader to find the area of this triangle, they would probably struggle because they'd be like, there's no numbers. But they would know the formula. Do you guys remember the formula from 7th grade? Maybe 8th grade. 8th. So base times height over 2, or I always write it as 1/2 times base times height. In this case, we're kind of stuck using which two sides for base and height. It's got to be A and B because they have to be perpendicular. So there's no way we could use C for a base. Well, we could, but we'd have to find some other piece of information. So it's going to be 1/2 times A times B. All right, there's another way to find the area of this triangle without using B at all. We've got to use either A or B, and I'm going to say let's use A. I want you guys to think about if I asked you to write an equation for B that has B in it. What type of equation could you write me that would have B in it? You could write a sine equation. You could write it if it's going to have beta and B in it. You could write a sine equation or a tangent equation. Agreed? You could do a Pythagorean equation if we were allowed to use C. Let's write me a sine equation that's got B in it and beta. B and beta. Not a law of sines, just a SOHCAHTOA sine equation. We're allowed to use SOHCAHTOA here because it's a right triangle. Sine of beta equals what over what? Sine is opposite over hypotenuse. Did you have B over C? Yes? Could you take that equation and manipulate it to get B by itself, please? What would you do to both sides to get B by itself? How are you going to get rid of that over C? Multiply by C on both sides. Clear the fractions, basically. So you'd end up with C times the sine of beta equal to B. Agreed? All right, so we're going to take this thing, since this is B, so we just wrote an equation for B. We're going to take that and we're going to stick it into here. So now our other equation for the area of a triangle is going to be 1/2 times A, not times B, but times C sine of beta. So you might be thinking, like, why would we ever want to use that version? That looks way more complicated than 1/2 times A times B, right? I'm about to show you. You excited to see? 1/2 times A times B is only going to work if you have two sides that are perpendicular to each other. Only ever going to be if you have two sides perpendicular. This will work for any triangle. Let me show you how I can modify this triangle. I'm going to try and draw C about the same size. And I'm going to draw A, but A is going to be much longer this time. I'll leave beta where it was. Now B is over here. So A is longer, B is about the same size, beta is about the same size. Can you convince your, whoops, hang on. I got two B's here. This is supposed to be a C. Thank you. Could you please convince yourself that this is going to work for this also? Remind me, what was this C times sine beta? It was B, which over here was the perpendicular distance from the top down to the bottom. That would still be the case, wouldn't it? It's not B anymore, but this is the same size as this. So 1/2 times A is serving as our base, and then C sine beta is this dashed line right here. That is the height. So that formula would work for any triangle. So, but there's some specific information we need to use to find it. So if you guys will get your pink sheets out, on the back side there's triangle formulas. And we've got a formula for the area of a triangle. By the way, these formulas will be provided to you on the test. You do not have to memorize them. They will not be on the memorization quiz. Those are on the identities. So there's the area of a triangle. There's 3 different versions of this first one. 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. Here's how I remember it when I was forced to memorize it. It's always 1/2 times 2 of the sides, and then times the angle that's in between those 2 sides. That's how I remember it. The area of a triangle is 1/2 times 2 of the sides. Doesn't matter whether it's AB or BC or AC. But whatever 2 sides you have, then the angle has to be the angle that's in between those 2 sides. And if that's the case, if we've got all that information, then finding the area is just a matter of plugging this into a formula, typing some numbers into our calculator, and hitting enter. So, would you like to do an example? Let's do it. It's going to be awesome. Look at number 1. Do we know 2 sides and the angle in between? We got side angle side? Sweet. Let's write our area. Area is 1/2. I need 2 sides and then a sine and an angle. My 2 sides are 9 and 15. And my angle is 97. And we just need to type that in the calculator. We should probably check our mode. Do we want to be in radian or degree mode for this? Degree mode. Agreed. Agreed on degree. I'm using 0.5 in place of a half. Oops, not divided by, times sine 97. I'm coming up with 53.6. If we round to 1 decimal place, that's getting us to 53.6. Not bad. 15. Let's try that again. How about 67? Thank you for catching that. A little typo in there. If I were rounding to 1 decimal place, that would be 66.0. Units would be what? 60. Man, I cannot buy a win today. Sorry. 67.0. It is weird to have this in the morning, isn't it? Units. Square inches. You guys know there's a difference between 67 and 67.0? Did you learn that in your science classes? So if somebody writes down on a technical, some blueprint 67.0, that means that it is accurate to within 1/10 of an inch, or whatever you're talking about. Where if you just say 67, then that means it's accurate to the nearest inch. So if I handed you a machined part and I said this part is 67 inches long, you can assume it might be 67.4 inches long, or it might be 66.6 inches long. It's going to be somewhere close to there, within 1/2 an inch of 67. If I tell you it's 67.0 inches long, then it might be 67.05, or it might be 66.95. So it's going to be a lot closer to what I say. Does that make sense? Anyways, I don't know why we're talking science. I guess science is super, super useful and cool. Can you guys try this one? Try this one. It's kind of one of the big reasons we do math, if you think about it. if I didn't make another mistake, I think that's my answer. That'll do it. Only one off, huh? 32. All right, we feeling okay about this? Any questions before we move on? Yes. 27.8, is that what you guys had too? Nope. Okay. Check your mode and make sure you're in degree mode. You are? Typo maybe? Oh, yeah, you have 15 instead of 11. That 15 wants to be an 11. Do you know the trick? You know, you can hit second enter and you'll get back the last thing you typed and you can go back and change it. You guys didn't know that? Oh, that's so useful. So much time. All right, so that's one of our formulas. Now, could we use that formula for number 3 and number 4? No, because we don't have any angles. Okay, if I wasn't going to give you another area formula, how would you now tackle number 3 or number 4? What would your process be? We could do a law of cosines to find one of the angles and then use this formula, but that's a pretty tedious process. There's a quicker way to do this. Okay, it's not quite as easy as the first way. It's like 3 times as hard. Yeah, but 3 times like a really small number is still a pretty small number, so you're not going to find this super difficult. Now, this formula looks messy. If you look at your pink sheet, this is called Heron's formula.